the agent produced this action, not the external influences. Of course, the external influences were there, but by free action, we mean that the agent himself produced the action. And finally, an action can be counted as free if it is an action that the agent could have avoided. So the idea of could have done otherwise has occupied philosophers for a long time and has played a huge role in free will debates. The idea means the following: if a person makes a truly free choice, then even if everything has been exactly the same up until the moment of choice, the person could have chosen something else instead. Next, the third major approach to the free will problem is a very different and peculiar reaction to the problem and is known as compatibilism. In contemporary philosophy, compatibilism has been a widely adopted approach to the problem of free will. Perhaps the most widely adopted approach. Compatibilism claims that free will is compatible with determinism and does not contradict it. In other words, if we accept the existence of free will, it is not necessary to maintain that determinism is false. As usual, there have been many versions of compatibilism in the history of philosophy. Classical compatibilism treats freedom as being able to do what you want, and it is compatible with determinism. I'm going to discuss one compatibilist approach to the free will problem recently developed by the American philosopher Harry Frankfurt, because it fits with what I intend to say in the last part of my talk. Sorry, I very much like this approach. So this version of compatibilism includes several very important distinctions. One important distinction between humans and non-human animals is the fact that humans can have desires about desires. Humans are capable of having complex mental states, the so-called second-order desires. So let me give you an example. I am going to tell you, a personal secret. I smoked for 15 years. For 15 years. 1, 5, 3. Most of the time I was smoking, I wanted to smoke cigarettes. Most of the time. I liked it. This was my first order desire for many years. Even though I had this first order desire, very often I wished I didn't want to smoke cigarettes all the time. I wished I didn't want to smoke cigarettes all the time. So that was my second order desire. So at the same time, I had the lower level desire to smoke cigarettes and the higher level desire not to want to lower level desire. It doesn't mean simply that I had two desires that contradicted each other. So let me clarify this point one more time. At the time I was smoking cigarettes, I used to have first order desires Sometimes I wanted to smoke cigarettes. Sometimes I didn't want to smoke cigarettes and wanted to smoke cigars. Sometimes I didn't want to smoke cigars, but I didn't want to smoke cigarillos. Sometimes I didn't want to smoke at all because I was sick, and so on and so on. But at the same time, I always had the second order desire. I wished I didn't want to smoke. This capacity of human beings to have the second order desire is what allows us to evaluate ourselves in a reflective way. We can think about ourselves, we can step back for a moment and think about what we desire and whether we want to continue desiring it. Non-human animals, like cats and dogs, and even human animals like children, can presumably have first-order desires, like desires to eat, to drink, and so on. But later, all the question. But they cannot have anything as sophisticated as second-order desires. I doubt that cats are capable of thinking they wish they didn't want to eat mice. I doubt. The notion of second-order desire provides compatibilists with a novel account of the problem of free will. Contemporary compatibilists claim that a person has free will only if the desire this person wants to have is effective. It sounds a little bit strange, I will explain it to you. Effective desire. Contemporary, so only if the person's desire is effective can it be called free will. So the core idea is roughly that a person has free will if she or he acts on the desire that he or she wants to achieve. So let me explain this idea in detail using the above mentioned example of smoking. As I told you a couple of minutes ago, when I was smoking, on the one hand, I had one desire, the desire to smoke. And on the other hand, another desire, the desire not want to smoke. And I hoped that my desire to abstain from smoking, to get rid of smoking, would prevail over my desire to smoke. I was successful, and my second order desire to abstain from smoking did prevail in the end. I do not smoke. I am not smoking. My desire, my second order desire did prevail. It was successful. Yeah, I was successful. According to compatibilism, I experienced an episode of free will. Free will is the case when desires become really effective. In other words, to experience free will means to have a desire that is effective in guiding a person's behavior. I don't smoke now. So my desire was effective because I stopped smoking. And you can observe it, you can watch, and you can see that I do not smoke. In my example, so I wanted my desire to abstain from smoking to prevail. I wanted this desire to be an effective desire. So if my desire to abstain from smoking did prevail, then I got the will I wanted. That means my will was free. Well, what can I say? I have to admit, I am very lucky because I am a person who experienced free will. So there is only at least one person in the world who experienced free will, who enjoyed free will. It's me. So let us go to the next step in the compatibilist journey into the free will problem. I'm going to introduce the last important distinction, namely the one between freedom of will and freedom of action. Please bear in mind this distinction. I'm going to use it in the last part of my talk, and so even tomorrow. Freedom of action and freedom of will. As I mentioned before, some creatures have no second-order desires. Non-human animals and children have only first-order desires. Does it mean that they lack freedom? So that they don't have freedom? So well, a compatibilist could give the following answer to this question. An agent's actions are free insofar as they stem from their desires. That is, if they had desired differently, they would have acted differently. Non-human animals and children have first-order desires. It means that they can act freely. But the crucial point is that this is merely freedom of action. Moreover, a person can act freely in another sense. Unlike non-human animals and children, a person has second-order desires. A person has freedom of will insofar as they can control their first-order desires. Second-order desires, and they can bring their first-order desires into line with them, with second-order desires. And non-human animals, a human baby and a human adult can act freely, but in different ways. The first two are free only in their freedom of action. The last one, a human adult as a person, is free both in freedom of action and in freedom of will. Perhaps it might sound paradoxical, but as a person, I can behave unwillingly free. When I was smoking, I desired to smoke cigarettes and cigars and cigarillas. So that was a question of my choice. I was free in my choice, but I was unwillingly free. Because when I was smoking, I wished I would abstain from smoking at the same time. And I wasn't free until the moment my desire to stop smoking prevailed over my desire to smoke. At that moment, I became willingly free. Okay. Careful. It's getting harder. It is not clear whether contemporary neuroscience supports the idea that we can experience free will and supports the idea that we can experience free will and make free decisions or not. So in the second part of my talk, I am going to consider some experiments recently conducted by neuroscientists that many people find very, very disturbing for the very notion of free will. The so-called free will experiments go back to the late 1970s and early 80s. a couple of decades before that time, in the middle of the 20th century, German neuroscientists explore the relationship between brain activity and voluntary motion. So they instructed the participants of the experiments to flex their fingers quickly during the session. The scientists, so sometimes it was wrist, it doesn't matter, to flex wrist or finger. So the scientists were interested in the relationship between electrical activity in the brain and voluntary movement, and particularly in the timing of electrical activity in the brain and voluntary movement. So they used two devices to test it. So to measure the electrical activity in the motor area of the brain, so they used the so-called EEG, electroencephalogram, and to measure the relevant activity in muscles associated with flexing fingers, they used the so-called EMG, electromyogram. So these scientists ran many trials. So what they found was that there was a reliable pattern of electrical activity in the motor area of the brain that preceded the electrical activity in the muscles. So the brain activity that they identified started so about a second before the activity in the muscles. So the timing is about a second. So the brain activity, so it means that the muscle activity that generated flexing a finger is preceded by growing activity in the motor area of the brain, and this activity in the motor area of the brain begins about a second before the muscle activity. And natural interpretation of this is that the brain activity reflects the preparation for the voluntary flexing of the finger. So technically, it is called readiness potential. So the time when the brain is getting ready to produce motor behavior. Neuroscientist Benjamin Libet, who was a professor at UC University of California at San Francisco, used these results in order to explore the problem of free will. Libet realized that the work of previous scientists gave him methodological tools for exploring the relationship between readiness potential and conscious intention to carry out the voluntary act. So he wanted to know what the relationship was between your conscious intention to do something and the brain activity that prepares you for performing that act. So the earlier work on readiness potential gave him a really nice framework for answering this question. Flexing a finger or a wrist is a simple voluntary behavior, and we already know something about the timing of the initiation of this motor behavior. We know 1 second before I start moving my finger, so there is an activity in motor area of the brain. But there was a serious problem. So Libet wanted to measure not that what was measured before, had been measured before, but so he wanted to measure the relationship between the conscious decision to flex a finger and muscle activity. So he realized that if he asked people to express verbally the precise time they decided to initiate the movement, it would have taken some time to produce the verbal behavior. It would have taken some time because the brain would have had to get ready to produce the muscle activity for speech. So probably Vasily understands. And since we are ready, so we are talking about very, very small time frame. So less than a second, just a second. So Libet needed to find some way of measuring the timing of the conscious decision to flex our finger before we do it. So the way Libet set up the experiment was as follows. He asked participants in the experiment to flex their fingers whenever they wanted. And as in the earlier experiments, the brain activity was measured by EEG, and the muscle activity was measured by EMG. So in addition, participants were watching a dot moving around a huge clock face. So the dot moved around very quickly, rotating in about 2.5 seconds. So 2.5 seconds. And what Libet asked participants to do was to notice where the dot was on the clock when they were first aware of conscious desire to flex their finger. So when I got aware of my desire to flex the finger, I had to notice the dot on the clock. So they had to notice and remember the place and then report it later. So this allowed Libet to determine the relationship between when the participants were aware of the urge to flex their fingers and when their muscles began to flex. So for each participant, Libet collected measurements from 40 trials. So let us suppose that you were asked to take part in Libet's experiments. All you have to do is the following. You have to flex your finger whenever you want. But when you first feel the conscious urge to flex your finger, you have to notice where the dot is on the clock face. Remember the position of the dot and say it later. So the scientists who would conduct such an experiment with you want to know two kinds of relationships. Firstly, the relationship between when you seem to be aware of the urge to flex your finger and when activity in your muscles occur. And secondly, the relationship between when you aware of your urge and when the activity in your brain motor area is happening. So two relationships. Libet wanted to measure the exact timing for both relationships. Some prominent scientists suggested that the way it must work is as follows. You make a conscious decision to flex your finger. And that has to happen before the readiness potential in the brain. So before the motor activity starts in your brain. After which your muscles are activated. So first decision, then motor activity, then muscle activity. So this seems to be a natural way of how it happens. First you decide to flex your finger. Yeah, I decide to do it. Then these decisions get to the motor area in your brain, and the motor area starts preparing for the action, and after that it gets signaled to your muscles. Okay. As in the earlier experiments, Libet found that the area in the brain started its activity about half a second before the muscles became activated. So, with regard to participants' conscious awareness to move their fingers, they reported it as being only 200 milliseconds before muscle activity occurred. That means it occurred about 300 milliseconds after the start of the brain activity in the motor area. So, in other words, the motor activity in your brain begins over 300 milliseconds before you become aware of your urge to move your finger. Again, so I thought that first decision, then brain activity, then activity in the motor area, then muscle activity. Okay, that what was made by Libet showed another picture. First brain activity, then awareness about this brain activity, and then muscle activity. Strange. Libet's own interpretation is what happens here is that the brain unconsciously initiates the process of voluntary action. You unconsciously decide to move your finger, and only subsequently you become aware of your intention to act. So let me summarize this strange point again. So what Libet finds is that the brain activity associated with preparing for motion occurs several hundreds milliseconds before the person is aware of their urge or decision to move their finger. So these results attracted a lot of attention. Libet's work started an enormous discussion across many disciplines, such as philosophy, psychology, economics, law, neurosciences, and so on. So what are the implications of Libet's findings? Many philosophers and scientists have taken Libet's experiment as a strong indication that free will has to be an illusion. Libet himself had a very sophisticated view on this issue. He thought that his experiments helped to locate where and how free will works. According to his view, we have a brief window of opportunity for free will. There are about 100 milliseconds between awareness of your urge to move our finger and the muscle activity. And it is during this very short time frame that we can exercise our conscious free will. As Libet put it, we can consciously veto the decision that our brain makes unconsciously. My brain unconsciously makes the decision to flex a finger, but later, consciously, I veto this decision. I do not want to flex. Okay, so let me be more specific about the timing. So participants of the experiments reported their awareness of the urge to move their finger about 200 milliseconds before the muscle activity, so before they flex their fingers. Physiologically, during the last 50 milliseconds, it is not possible to stop the muscle activity. If you get to the last 50 milliseconds, it is unavoidable. Libet thought that there was still enough time for the so-called veto. So he then set up another experiment in order to show this. So this time, he told participants that they should prepare to flex their fingers at a certain time, but at the very last moment, not to do it. Again, he measured the electrical activity in the motor area of the brain and in the muscles. What he found was that the readiness potential emerges about a second before pre-planned muscle movement. And in the first several hundred milliseconds, it increases. However, between 100 and 200 milliseconds, before the pre-planned movement of the finger, it decreases. So during this very short period of time, participants in the experiment could intervene and stop the pre-planned action. So Libet concluded that participants were using their free will to veto the action at the last moment. So that means we don't have free will to initiate our decisions, but we do have free will to veto the decisions initiated by the brain. So as Libet put it, we don't have free will, but we do have free want. Libet thought that this capacity for free want is generated by truly free, undetermined choice and allows our consciousness to be in the driver's seat, so to speak. So although many philosophers and scientists have taken Libet's experiments as providing evidence against free will, Libet himself was a libertarian with regard to free will. According to him, veto experiments provide evidence for a libertarian view of free will. But there is a question about what generates the veto itself. It is possible that the veto is also caused by a brain activity generated unconsciously. So, as I already mentioned above, Libet's experiments generated an enormous discussion among researchers from many disciplines and encouraged neuroscientists to conduct new experiments on free will, one of which was done by a group of neuroscientists in Berlin. I would like to demonstrate a very short fragment of a BBC documentary in which a mathematician from the University of Oxford took part in a free will experiment at the Berlin Center for Advanced Neuroimaging, led by neuroscientist John Dylan Haynes, whose article, coincidentally, we are going to discuss at the seminar class immediately after my talk. Okay, now I need to change some things here.
I think as humans we pride ourselves on the fact that we can make decisions. My free will means that I can decide whether I'm going to take this on or not. But science has a problem with free will. Science likes one thing to cause another. Okay, if you think there's some sort of separate I, which is separate from my body, then that's fine. That's what's helping me to make my decisions. But if you think I'm just a load of biology, then I think you've got a problem about free will, because what is making those decisions? Is it just a sort of ebb and flow of neuronal activity? I'm in Berlin to take part in an experiment designed to explore the source and timing of my decisions. I'm quite apprehensive because the results could have a profound effect on how I live my life. They will reveal who is in charge of my decisions. Is it the conscious me, or an unconscious mass of grey matter that I have no control over? So this is going to be looking at my brain. Yeah, this is looking. Another day, another scanning. The experiment is simplicity itself. I have to randomly decide and then immediately press press one of these left or right buttons. At the same time, the scanner system records when my brain made the decision, and the computer when I physically pressed the button.
Okay, Marcus, we understand. I'm ready to start.
The test didn't take long, and to be honest, it's not terribly exciting. But I'm hoping the results will be a bit more interesting.
In your case, up to 6 seconds before you make up your mind, we can predict which decision you're going to make.
6 seconds?
Absolutely, 6 seconds, yes.
6 seconds? Oh. So I was conscious of making a decision to press my right finger down, and you're saying that 6 seconds earlier, my brain had already made that decision?
Exactly. So here we can show you how we did it. In this region, there's a pattern of brain activity that emerges before you make up your mind that tells us which way you're going to decide. And these blue regions, they get more active when you're going to choose left, and the yellow regions get more active when you're going to choose right.
That's a bit frightening. It sort of implies, therefore, my conscious decision is a very secondary thing to my actual brain activity.
Absolutely, absolutely. It seems that there's a lot of unconscious brain activity going on that is shaping your decisions, and that your consciousness comes in at a very late stage in a decision.
So that's rather a frightening idea, that that I'm sort of hostage to neuronal activity that's happening 6 seconds earlier. I
But
mean,
I wouldn't call it a hostage situation, because thinking of it as a hostage implies a dualism between your conscious mind and your brain activity. But the conscious mind is encoded in brain activity, it's realized by brain activity, it's an aspect of your brain activity. And also the unconscious brain activity realizes certain aspects of you, it's in harmony with your beliefs and desires. So in most cases, it's not going to force you to do something you don't want to do.
so what do you think this has implications for the whole sort of study of trying to understand consciousness and what I is inside here?
Well, absolutely. I think if we find that a person's thoughts are very closely encoded in their brain activity, we can't make a distinction between these thoughts